Thank you, and welcome to this panel. The structure of this little session will be that first I'm trying to give a short introduction to Copernicus Data Space Ecosystem to those of you who might not really have heard about what this is or how it works. And then afterwards we will discuss the challenges and opportunities, and in the final minutes of the panel discussion we hope to answer the questions from you through Slido from the floor. So go ahead and use Slido. For the introduction to Copernicus Data Space, I have a presentation. Let me go through that. Yes, it's a very big system, so it's difficult to introduce in 5 minutes, but they say if you can't introduce something in 5 minutes, then you don't really understand it, so the challenge is on me. We all know that the Copernicus program is the most ambitious Earth observation program to date. We have a massive selection of satellite platforms and a huge amount of data that is coming in and that's available to anyone for any application. And the big challenge is really how to put it into practice. So how to make actionable results, how to make actionable information from the pixels that are collected by the satellites. This little example is cap monitoring. Of course, it's the most data-heavy application, civilian application of Earth observation to date. On the example of Slovenia, where as we progress throughout the year, the evaluation of the agricultural parcels moves from yellow, so uncertain, to green, certain, by processing the satellite data in a big infrastructure in the background. So Copernicus Data Space Ecosystem is a data infrastructure. So if we have the typical processing chain of accessing the data from the data storage, the warehouse where it's stored, carrying out some sort of operation, a query, a spectral index, a selection, a filtering, and then from this extracting quantitative information and showing it on the user's computer, then Copernicus Data Space Ecosystem is essentially the connecting links of the chain, the little white arrows in the image. It's the infrastructure. If it's good, then it's invisible, then it's in the background. But the revolutionary thing with Copernicus Data Space Ecosystem is this massive application of cloud computing. So a couple of years ago, you would have downloaded the data from the server onto your computer locally, and then you would do the processing and the data visualization on your own computer. And then this meant that the limitations of your computer applied to what you could do. Now, this is completely changed. Your computer is just an interface. You can have a potato computer, a very old computer, and still you will be able to access and process terabytes of data, because the processing is actually taking place on the server side. Even the rendering for the visualization of the results is taking place on the server side, and you are just looking at it through an interface. Copernicus Data Space Ecosystem is a big system with many different components. I mean, at the very core of it is Sentinel data. And one of the big steps compared to the Copernicus Open Science Hub is that all the data, all the Sentinel data are available for immediate access. There's no rolling archive. You don't have to wait for packages to be put together for you. It's just there for access. The Sentinel data is complemented with Copernicus contributing missions and other additional Earth observation data. And on top of this, we have various families of APIs. So an API is a machine-to-machine interface. It's a bit of code that allows the software running on your computer to connect to our backend and to answer questions that your computer raises, to give exactly the right data product, exactly the right data set that you need. And this enables Copernicus Browser, a very easy to use, very intuitive, simple browser tool that works in a web browser and that allows you to look at satellite imagery and perform smaller analysis tasks. And we also have a massive code base, because we know that it's difficult to train Earth observation professionals, right? It's difficult to become a ninja in Earth observation coding. But we are trying to make this easy by providing step-by-step instructions and training materials, and also an online code lab, so you don't need to install anything to start working with Earth observation data in code. It's all online. And then we have cloud computing capacity, and we have federation. So put together, this is the open ecosystem. This is Copernicus Data Space Ecosystem, a system that's larger, stronger than the sum of its parts. Again, the old way of working with data is that you download predefined tiles, you have to store it on the client side, you need server capacity, big machines to process it, and this makes it difficult to scale up. If you have an application that works on your little computer locally, and now you want to release it at national or regional scale, then you need a big machine, then you need fast software. But with API access, this is all done in the infrastructure. You can access the data directly for your area of interest immediately. You don't need to store raw data because what you're downloading is directly your data product. And the virtual machines that you want to use for machine learning processing or advanced applications, they already have the data on board. So this means that much less investment is needed and the scaling can be absolutely dynamic. So just a very quick look into the browser. This allows quick search and query and download of all the products. It allows interactive visualization and analysis of the data collections. You can export subsets of the data, including for your bedroom wall in print quality. You can do comparisons and time lapses and area analysis, statistics, directly in an online interface, again without software. And you can even explore data in 3D. So this is a teaching tool. This is an outreach tool for people who don't have skills for working with Earth observation. We have these interfaces for code development. So the Jupyter Lab, which is an online onboard system directly accessing the data collections with all the dependencies pre-installed. You get a small server and you can start working on it without setting up your own system, and it works with various different API families. We have OpenEO, which is, again, an amazing tool because it's code agnostic and data format agnostic. These were the two main limitations. What data format should I use? What coding language should I use? OpenEO bridges all of them, and it allows you to create a really advanced data processing chain, including with visual interface tools or in code, that then scales very nicely. And we even have the Algorithm Plaza, which is a system for marketing or sharing processing chains in OpenEO that other people can use. So again, the transferability of the system is really well enhanced. Then, on top of the data space, we have CREODIAS, which is the commercial element. So this is a cloud computing system. It offers services for data processing, various ways of serverless processing in a commercial, competitive way, but with the data collections directly on board. So this is Copernicus Data Space Ecosystem. As you see, this is a platform where you can build many, many things. It's like Lego. So we need you to contribute data sets that you want to share in this platform. You can also contribute code notebooks or tools that other people can use, because this is a highly collaborative, publicly owned system. So put together, I think Copernicus Data Space Ecosystem is really the classical example of a transformative solution. Different components that together rise above what would be enabled by them individually. We have this connection of data and code and processing capacity, which is really hopefully changing the Earth observation industry. Thank you for your attention so far. Don't forget to submit your questions in Slido, and then I move over to the panel. Thank you. So introducing my panelists once more, we have MARQUARD from T-Systems, MONIKA KRZYΖANOWSKA from CloudFerro, and Dennis CLARIJS from VITO. And the question we want to address in this panel is really, what are the main opportunities and the main challenges towards the implementation of Earth observation data in climate solutions? What is actually holding us back? What is the main difficulty? Who's going to start? Monika, can it be you, please?
Okay, I can be the one to start. I just have few notes, don't worry, I won't read it through. Just that I wanted to be a little bit in the context. We had this paradigm of moving the processing to the data, but 6 years ago, or maybe 7, we were thinking about maybe up to 1 petabyte of the data. Today, we have over 70 petabytes, and 1 petabyte, 1.5, this is the amount of data used by one project daily. So we moved our expectations by solving initial requirements. Because, of course, from the beginning, the requirements were to have the data available immediately, all the data for easy processing. We could do it by selecting right technology, yes, CEF, open source, no vendor lockup. So this is one of the very important elements. And the second aspect is that the data that you access are unzipped. You don't need to download the data. You can just mount them as a, see those data, those imagery as a file. just mounting them with an S3. So those are the solutions that are still working. The amount of data is growing. So for the time being, we are quite safe, and we can grow the data. We can say that we will have them. We are becoming used to use access to the data as computing services as commodity. So really, we shouldn't even think about it. And I think that the next challenge that we see is that we don't anymore want to bring algorithm to the data, because we are all doing it every day when in the life. Now we want to bring user to the information that was extracted from those data. And I think that with this comment, because it goes above what CloudFerro is doing in the project, I will pass, I don't know.
Yeah, good afternoon, everyone. Yeah, maybe I can address the challenge of scalability, to have this much of data, more than 70 petabytes of data. And if you look at the future, all the expansion missions and new data sets coming up, that will give enormous new challenges, in which you will need scalability, but also probably lots of new AI or nifty things to work with the data. But at least the scalability needs to be there. And that was, if you look at it, indeed, 7 years ago, a lot different. There you had lots of limitations and different data sets all over Europe. That changed. And certainly with having set this landscape now for the Copernicus Data Space Ecosystem, this is really a solid base for growth. Also, when I look at it from our perspective, also from a research organization perspective, we needed a team for setting up the scalability. It took a lot of effort to set everything up in terms of cloud computing interfaces, metrics, reporting, and was a lot of hassle. It can still be, but I think with the new APIs that are introduced into the system, like OpenEO, like the streamlined data access of Sentinel Hub, much of these things are hidden, which makes things more consumable for end users. I don't dare to say that it's accessible for everyone. You still need quite some knowledge, computing knowledge, to handle the data, but at least a very subset of tasks are abstracted from you, and you don't need to worry about it anymore. So the workflow and the scalability that the system offers is a lot more than it used to be a few years ago. So,
thank you. Any additional challenge? What do you see as the next step or the difficulty?
Yeah, thank you. I mean, we have all those data in place now. We have this big repository of data, but we heard about this before here today in various panels. If we want to put this into operational services, one of the key aspects is also at the end trustworthiness of the information we generate. And the foundation of generating trustworthy information is obviously to make sure that those information are based on data which are reliable, so the integrity of the data is super important. And if we put this into perspective, what we can offer on CDSE, we have there the traceability service, which allows everybody to trace back where the data comes from, how it has been produced, what is the origin of the data, etc. So I believe in terms of trustworthiness, and this was one of the Slido polls actually where this appeared really in the center. This is one key aspect. Another one is interoperability. I mean, the key information we can generate and the more value add we can generate is actually if we combine data and if we can do it in an easy way, in a simple way. So, and this has different aspects. So, and in CDSE, we look at this from various perspectives. So one is the more strategic perspective. How can we interoperate in future and how can we take advantage of the programs like Gaia-X, like the Simple framework, which are currently implemented. At the same time, we also need to make sure we can do it now, and we have pragmatic solutions in place as well in order to do so. And now coming back to CDSE, for example, data or federation of services is supported by OpenEO, by the OpenEO orchestrator. Maybe Dennis can elaborate a little bit more on that. From that perspective, yeah, we really look at this in a pragmatic way, in a practical way, as well as making sure from T-Systems side that in future we will also apply all those frameworks like Gaia-X, like Simple, and make this a really working solution, future-proof solution as well.
Thank you. I think I can connect to this. I mean, we have talked about data volume, about scalability, about trust, and now that, I mean, I'm communicating about Copernicus Data Space Ecosystem for about a year now, and I often see the limitation that simply the opportunities are too broad now. People are hesitating, which tool shall I choose, which API shall I choose, because we are still in the stage of early adoption. There's not that many examples of successful use that we can showcase. And so with OpenEO, Sentinel Hub, Stack, OData, we have all these families of tools. And if somebody chooses one, of course, they're not locked into it. It's possible to move away, but still you've invested energy into that. And I perceive that, especially for government agencies, this selection is holding people back a bit. The way, I think, to break this boundary is to talk about real-world use cases, to talk about examples where something has been achieved using Copernicus Data Space Ecosystem. And because of this, I want to talk very briefly about one of our champion users, the Finnish environmental agency, Syke. They have I mean, we all know that Finland is the land of 1,000 lakes. Of course, in reality, they have more like 10,000 lakes. And they are monitoring these lakes with satellite data. And that meant they are using this since 15 years now, so ever since the times of MODIS. They had a massive data center, and now gradually they have actually shifted all the load, all the processing to Copernicus Data Space Ecosystem using Sentinel Hub APIs. They are not downloading Sentinel satellite imagery anymore. They're processing it online, they have their own front end, they're deploying the data out there, and they're actually super happy with it. So this is an example where they made the choice. They actually built a very heavy processing chain on top of our architecture, and it's happily handling it. So I would like to prompt the panelists to share additional case studies or use examples. What's coming next? Dennis?
Yeah, I can start. We have several examples, actually. Maybe the most prominent one is the Copernicus Global Land Service, where it was in the past handled in our data center at VITO, and now we're seeing a shift towards the CDSE. Not only the processing, the whole cloudification of the processing chains, but also processing on the Copernicus Data Space Ecosystem. There's a shift towards as we speak. But also the whole integration of the products that are coming out of the service. So that means that they will get integrated into the different catalog systems, into the viewing applications, or the EO browser, or Copernicus browser, sorry, into OpenEO. So you see much more fixed integration coming up, a shift towards CDSE, rather than having a scattered landscape, which is beneficial, I think, for a lot of users to work in a unified way with the data. Another use case is well, we have several on agriculture, but maybe another one on climate, as it is one of the topics here in this panel. Is I recently talked to, in Belgium, there's a new group called CERAC. It's the Climate and Environmental Risk Assessment Center, and it's actually a new group set up last year to advise the federal government on everything related to climate risks, adaptation, mitigation, and so on. They also have to monitor the planetary boundaries of Belgium in several ways. So they're also really looking into the direction of having Earth observation data, but they don't know really where to start. And that's I think what we are trying to do now at the CDSE is make more use cases, make things more aware. So that is very, very important for us also to push forward. And if you then say these examples on let's say soil moisture or burn scars and so on, they're really surprised that it's there. So we really have to educate the people, and then they're getting interested to use the system in the end. So I think these are some use cases that I could share.
Okay, so maybe I will share just one and indirectly related to climate, where in a project a number of open sunshades on Greek coast helps to estimate the revenue from tourism for the season.
Okay, one example which I see is urban planning. So there is quite some things to be done, and like for example, how do our cities deal with the fact of global warming? And it's getting warmer in the cities, so there needs to be some countermeasures in actually to do something about it. And we've seen a very interesting project, which is still a pilot project of a city in Germany, where they use satellite data, Sentinel data in particular, but they also combine it with data from the Climate Data Store, and they derive actually the hotspots in the city, and then derive from that actually what are the countermeasures in terms of planting trees, for example, generating more green areas, etc. So this is one example. It's not operational yet, but it very much shows it can be an operational service. And in Germany, for sure, all the cities have to go through this planning. That is something I see where there's a lot of potential, and also there's a lot of business to be done. And the Copernicus Data Space actually has all the means in order to develop solutions for this without even investing any money in it, because the resources are already there. And this is an appeal to everybody here. So in this room, use it and really also join the ecosystem, because that's what we at the end have to achieve in order to make it a really successful ecosystem, that everybody contributes to it.
Thank you. I think we are moving to the questions from Slido. So the top one at the list is how is proprietary software from companies protected in CDSE? I think this question is mainly addressing CREODIAS, where companies can onboard their services. Monika, can you tell us a bit about the protection of commercial services or proprietary tools in CREODIAS?
Okay, well, you have standard IT protection, security measures and intrusion preventions, but at the very end, it's the owner of the software who must build it in a way that will protect it. We provide protection of cloud environment. And of course, there are legal aspects that protects our IPRs.
Thank you. I think that's a clear answer. I have to hand the next question to Dennis about OpenEO and commercial applications. What do you think, Dennis?
One answer, yes, absolutely. I think the user has a wrong impression of the messages he gets, but absolutely OpenEO is there. Either it's an open source component, I haven't mentioned that, but you can add your experience or tailor OpenEO to your liking, but you can also build upon OpenEO, and there's a free tier available with quite some processing capacity for each user in a fair manner, where you can start in a small, let's say a small way, field level, city level, and then you can scale up from there. We have use cases going from field level up to continental scale processing of crop mapping, for example. So it's certainly possible. And even so, if you have, for example, a new algorithm, a new model, OpenEO can be used for model inferencing as well. Then you can also onboard it in what we call the algorithm plaza. An algorithm plaza is this sort of a marketplace. I don't like the word marketplace. It sounds too commercial, but it can be commercial. And you can onboard it in there, make it very visible as a building block towards other users, and other users can then reuse your building block, and you can either get a return if the usage from this building block is above a certain level. So if it's used a lot, then there can be commercial agreements in place where you get a return from the models you have or the algorithms that you have there. So yes, absolutely, that's the final answer to this question, yes.
Okay, there was a question about efficiency of CDAS. I don't see it anymore, but I would like to comment that currently, first of all, our ecosystem is the first to have the data. The data are coming first to the CDAS. And then today, the endpoint for the data is as efficient as any other. So there are no technical limitations for the usage. Thank you.
I want to add something more on this question on how we can compete with platforms offered by Big Digital in the US. I think this is the most burning question for a lot of us. And the answer, of course, is trust. So this is a publicly owned platform. And also there's a long-term commitment to sustaining it. At the moment, we have an agreement in place for 6 years. The 6 years is limited by the EU budget cycles, but we are working hard to have it extended to a longer term. And since this is part of the Copernicus program, I mean, the platform itself, I think that the long-term stability of the platform can be expected. And this is a very important aspect if you are deciding on what to invest in. We are coming to the end of our time for this panel. But before we leave, I think I want one final round of statements on what you as partners would want to encourage the industry to do. What do we want from our industry partners and users? And I think I can start this one because the first thing we want, I think, is that if something is working successfully, then please make a noise about it. I mean, usually if something is going wrong, then you are waving a flag. But it's also worth advertising successful solutions because on one hand, people will learn from them. On the other hand, people will come to you who want a similar solution. So spreading knowledge and especially sharing successful use cases is a very important point in the acceptance and adoption of the ecosystem.
Yeah, as already said, I think we would like to encourage value-adding service companies to really also join the ecosystem. We are currently finalizing really the criteria to become what we call then participant, where you can also have the possibility to advertise your services actually on the platform. And so it should be hopefully simple and just reach out to us and we will guide you along to become actually also participant of the platform or on the platform.
Yeah, not MONIKA. Okay. Yeah, I think I follow my colleagues here. My final message would be, I think, when you look back at the slides from Benjamin Kutz, you have the 5 A's. We're working on solidifying the first 2, availability, accessibility. I think from industry, expect the other 3 ones, and we will try to keep pushing them forward as well from our perspective.
Yes, and to build on all what we already said, our next challenge is what Irene said today, foundation models, artificial intelligence. Thank you.
Very relevant closing words. Thank you very much to our panelists and thank you for bearing with us for this discussion. Thank you.